As I said, I'm Isha Singh and I'm applied AI design and delivery intern with the Vector Institute. So one thing which I really love about Vector is that you can move into any room and you can stop and hear some new ideas and learn something new about artificial intelligence. Our sessions, whether it's Vector Business Insights, the roundtable conferences, all of those capture all those moments. But the issue is that the value of those moments, they're trapped in long, dense transcripts. And it's if it's very difficult to deal with the transcript, then it's difficult to extract the insights and share it with our community. So I thought, why not just develop something which captures the key insights from the transcripts in a way they're actually spoken during the conversation with the same reliability and accuracy. And that made me develop this AI transcript insights interactor, which has embedded verification in it. So let's understand Vector's mission and the challenge we face before I introduce this tool to you. So Vector's mission is that we keep on conducting several sessions around artificial intelligence, the state of the art. And once we have the transcripts from those sessions, we convert it into clear summary documents, which we can share with our industry sponsors, with the government, and the wider community. However, the challenge we face at this point of time is that these are the long, dense transcripts, and there are a lot of errors which are involved in the process from going from a raw transcript to a final structured report, which you can share with the community. So this is how the raw transcript looks like. As you can see, it's the same person, Jason Lin, but the spelling mistake is there. A normal session, it contains around 24,000 plus words of unstructured text. This is for the transcript. And then again, there can be the speaker attribution unclear or inconsistent. And the key insights, they are trapped inside the long discussions sessions. So it's very difficult to extract them. And then on the right side, we have the final report, which we usually share with our community. And then it has a consistent structure, it has the accurate speaker attribution, and it's ready for the external distribution. But as I said, that between this process, there's a gap. There are a lot of error which happens. And my tool aims to solve those errors. So let's understand the current process which we have. So at this point of time, we use an internal tool. So that internal tool cleans the transcripts which we generate from Zoom. So it removes the timestamps, the name of the speakers, and all the noises, and it splits it by the speakers. And we then use it for generating the insights. So the reason why it's necessary is because, again, as I said before, we need to share the accurate summaries with our sponsors, and it's very important that every fact which is mentioned in the summary report, that's reliable and that's accurate. And there's a lot of manual effort which goes in. Even if we have the clean transcript, there's a lot of effort which goes in extracting the key insights from there. So, and this is the gap which the tool is designed to address. So before I begin introducing my tool, I would like to acknowledge the foundation layer, the tool which was developed by Uche, who's sitting in the room, the associate project manager. So his tool actually cleans the raw transcript. That's how the interface looks like. So we upload the raw Zoom transcripts, we mention the names that we need to remove, and it cleans and splits them by speaker. It normalizes the transcripts. So, this is the foundation on which my tool is built. It's because of this layer that we can automate the rest of the stuff. So thank you, Ujay, for building that. And then let's talk about the remaining gaps. So I was working on the ESS session which happened on the ICML 2025 conference, and I was trying to generate the summary report for that. And then I used Uche's tool to get the transcripts from there. And then once we have those transcripts, we feed it into LLM so that we can get the key insights from there. But then every single time I had to tell LLM that make sure everything is coming from the transcript. But again, there's this issue. If you have long, complex prompts, there's no guarantee that the model is going to follow everything, every instruction of yours, even if you mention it every single time. And if you're having multiple editions, And you have to mention it every time. It's a repetitive process, and there's no guarantee that you'll get accurate results. So LLMs ignore the grounding in the long prompts. Then, so we have sample files which we upload so that we can get the structure from there. We can tell ChatGPT or other LLM that, okay, this is the tone of the structure which you need to follow. But there are chances that there might be certain template leakage. There might be certain content from that sample file. It must be taken to generate the summary report. And then there's no automated way to check the fidelity. And there can be subtle inaccuracies which go unnoticed. So this made me realize that we needed a system which enforces grounding by design and not by repetition. And that led me to this solution, which is a two-layer guardrail system. So we have two coordinated layers here, each powered by Gemini 2.5 Flash, and those two layers are Writer AI and the Verifier AI. So the Writer AI is responsible for generating a structured draft, and then the Verifier AI is responsible for checking each and every line in the draft against the transcript. So you upload the files, the Writer AI checks, the Writer AI generates the first draft, Verifier AI checks it, and then we have a refinement loop. So in the user interface, we have a chatbot, which we can ask, make these certain changes. And then there's also this option where you can make the manual edits. So every single time when you make an edit, whether it's manual or through a chatbot, it goes through the refinement loop all over again. And when the user is satisfied, a docs report is generated. So let's go into each of them in detail. For the upload files, that's how the interface looks like. So you upload the transcripts, the example, and the bios of the speakers. It's quite optional, but the transcripts are necessary, and you can upload the transcript, all of them together or one by one. And then we have the Writer AI. So for the Writer AI, what it does is that there is a system prompt which it follows. So there's a specific structure which has to follow. So the structure is mentioned over there. Takeaways, recording, agenda table, session, speaker, and about the Victor Institute. And there are certain rules within that prompt that it has to make sure everything is coming from the transcript, there's no template leakage, and there is no hallucinations. So this was necessary because this prompt gives AI a clear blueprint. Now, I would say the most value which we're getting from is from the Verifier AI. So for the Verifier AI, it checks every line in the draft one by one against the transcript. So after going through the verification, it gives you the output in the JSON format, and it tells you exactly where the model drifted and where the things went wrong. So for the unsupported claim, so suppose there's something which was mentioned in the draft but wasn't there in the transcript, it's going to flag that. For the accuracy and attribution, it creates a speaker map, and suppose there's something which is mentioned that this was said by speaker 1, but actually in the transcript it was said by speaker 2, it's going to flag that. For the balance and the fairness, what it does is that it uses semantic clustering. So it assigns a weight to the speaker and the topic. So suppose if there's certain topic which has more weightage in the transcript but lesser weightage in the draft, it's going to mention that. And for the missing information, suppose there's some topic of the speaker which have been spoken about in the transcript but is not present in the draft, it's going to highlight that and it's going to place the placeholder over there, missing information. And then, yeah, it goes through the refinement loop all over again, and then you download the final report. So let's go through the demo. So here I have uploaded the transcripts, the example document, and then I click on generate report. Then this is the editor and verification interface. So this is the chatbot, this is the text box. So here the results are going to come out, and at the bottom we have the verification layer. You can see the results soon. Yeah, so this is how the document, the summary looks like, and then it shows the verification layer with 4 boxes. So about the Vector Institute, I embedded it into the code, but it wasn't present in the transcript, so it highlighted that. And then in the text box, you can mention that, okay, make it brief, it's going to do it for you. And then again, it goes through the verification layer. Yeah, so it made it very brief. Again, we got certain verification results, the same thing about the Vector Institute. Now, another thing is, as I said, we can make the manual edits to the interface, and even if you make the manual edits, it's going to go through the verification there. So here, deliberately, I changed Collab LLM to Notebook LLM, and then I click on Save Manual Edits and Re-Verify. It triggers the refinement loop all over again, and then you're going to see the results. See, Amrit's Notebook LLM is incorrectly used instead of Collab LLM. It just flags it right away. So that's all about the demo. And then, so for the early impact, I tested this tool on the same ESS session which I worked on because I had some information about what were the key insights and I was able to review it. So it had 4 speakers, approximately 20,000 words. And then we got a very structured report from the writer AI. So 20,000 words converted into approximately 1,800 words, 11 times reduction. But I would say the main value which we got was from the verifier. So it was able to got the real factual errors. So there were 3 presentations. There were 3 presenters mentioned in the transcript, but sorry, there were 3 presenters mentioned in the draft, but actually there were 4 speakers. So it highlighted that, and then there was some technical term error in the spelling, so it flagged that. And again, about the Vector Institute, it made sure there was no template leakage and there was automated grounding. And these are the results which I've got from the trial. So practitioner takeaway section, it had 3 distinct presentations. However, the agenda table and the speaker section list 4 distinct speakers. About the Vector Institute section contains information which is not present in any of the provided source transcripts. And then in unwritten summary, the term Rennie divergence is used, but the correct spelling is found in the transcript is this. And then this is how the final report looks like when you download it. And this is the exact structure and the formatting which the tool follows. So you don't have to do much editing, I would say. It's a very clean format. So you have the practitioner takeaways, the recording, the agenda table, and that's how the section for every speaker looks like. And then for the next steps, so I want to test it across diverse transcripts. At this point of time, I have only tested it on ESS. I'm going to test it on additional BBIs, ESS, and roundtable events. Then the second thing, which is the most important thing, and which I initially started with, was to make it on local LLM. But then the issue with local LLM is that the other people who want to test it out, they might have to download it. And Gemini was pretty easy. So in the future, I want to move it to local LLM so that we have full privacy and the transcripts remain internal. Then the third thing is that if the results from this tool is strong, I want to integrate it with Uche's tool, which is the foundation there, so that we have an end-to-end workflow. We upload the Zoom transcripts, it cleans it, and then at the end, a final report. And then for the conclusion, I would say that this is a tool which doesn't only does the summarization, but it builds trust so that we can share the reports quickly with our community. And then for the last thing, I would like to thank the design and delivery team, specifically Michael, Tahani, and Shine. Michael for his feedback on the tool, Tahani for all the support she has given me throughout the internship, and for Shine, which really helped me to put this presentation together. Thank you.
Mr. Meaton, you mentioned Zoom, so you're using the transcript on Zoom, or have you tested it like Zoom versus like?
So at this point of time, at Vector, we mostly record the transcript from Zoom only. So yeah, Zoom transcripts. Well, Michael really wanted me to do something with the local LLM, which can also record the transcripts, because Zoom transcripts are not very reliable. But yeah, I think this is also one of the next steps.
So in like the interface, you're like doing the refinement loop. Does asking the LLM to make a refinement overwrite any manual edits that you would have like made?
Sorry, I didn't get your question.
So you know how like in the video you showed an example where you said make it more brief, and then an LLM automatically made it more brief, right? And then you manually changed something in the script. So presumably you're going through this refinement loop. And let's say I see something that I manually wanna edit, so I'm like, that's wrong, I'll fix it. If I then ask it to make it more brief afterwards, is it gonna undo that manual change that I just did?
Well, to be honest, I did test that out, and this is something which I would really want to test. Thank you for pointing that out. But I did test that.